Hello. 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 You're also good. The Dynatrace sandwich. You don't know each other? The company's too big. I would say there is no school bell today, so let's just go ahead and start. Welcome to my talk. I'm super happy that you made it here. I want to talk about Kubernetes, how to utilize it for containers, how it's actually, at least on a very high level, working in the background, and also how to go further than just Kubernetes and actually utilize it for other things as well. But before we do that, I want to hear from you. That should be obvious. What is actually the first thing that comes to your mind when thinking about Kubernetes? Just tell me any word, no wrong answers, but just go ahead.
Complexity.
Complexity we have over here.
Containers.
Sorry?
Containers.
Oh yeah, containers. That's actually the first thing that I noticed when I started working with Kubernetes as well. My second association was YAML. I have to write a lot of it to get started with Kubernetes, and I'm super sorry for my slides. Let me quickly refresh them. Yeah, much better. And a lot of magic or complexity going on underneath. But then I started working with Kubernetes, and I started to learn that actually it's not that much magic. It's quite a bit of complexity, but it's quite understandable. And from this point on, when I started to get that, I actually started to explore all the possibilities we have with Kubernetes, how to extend it, and how awesome it actually is, at least in my opinion. So that's what I want to share with you today. But who am I actually to talk about all of that? My name is Katharina. Actually, everybody's just calling me Kathi. According to my job title, I'm a senior software engineer at Dynatrace, but since a few years, I'm working in the DevOps, cloud native space, platform engineering, and I really, really enjoy what I'm doing. Okay, enough about me, back to Kubernetes. Where is that weird name actually coming from? I had a very hard time remembering it in the beginning, and the reason it's derived from an ancient word that means as much as helmsman or pilot, and I kind of like it because it's like navigating or guiding us through the cloud. But what is it actually? To answer that, let's take a look at the definition of Kubernetes. There it says that Kubernetes is a portable, extensible, open source platform for managing containerized workloads and services that facilitates both declarative configuration and automation. Quite a lot, isn't it? So let's go ahead and break it down. First of all, Kubernetes is portable. This means Kubernetes can run nearly everywhere where you want it to run. You can either run it on-prem, you can run it on the cloud, you can run it both, you can run it in a hybrid version, whatever you want to do. It is extensible. I didn't really notice this in the beginning when I started working with it, but to me, this is one of the biggest superpowers of Kubernetes. Since the start, when it was open source, the Google engineer designed it to be easily extensible. And by that, we can plug in a lot of cool things that we're going to see later on. It's open sourced since 2014. It has a huge community. There are also lots of Kubernetes community events, conferences around it. Lots of open source tools have evolved. And that's also one of the reasons why I enjoy working with it so much. Yeah, it manages containerized workloads. I think we all know containers by now. And it facilitates declarative configuration. So basically, you tell Kubernetes, hey, I want to deploy this. And Kubernetes takes care of getting to that state and making your desired state the actual state. So you don't have to tell it, first do this and this and this. You just tell it, I want to have this, and that's all you need to do. Okay, enough about the definition. Let's see what you actually get when you deploy a cluster. I'm really sorry about the slides. Yeah. So when you deploy Kubernetes, what you get is a so-called cluster. In this cluster, there are several components running. And first of all, we have a node. A node is just a worker machine, no matter if it's a physical machine, if it's a virtual machine, it doesn't matter. But we need some place to run our workloads, right? So we have either one or, in more realistic scenarios, multiple nodes in our Kubernetes clusters. And on those nodes, we need some components running. First of all, we said we're running containers. So we need a container runtime on them to actually be able to run those containers. It can be container D, Cryo, Docker Engine, whatever you prefer. Then on each node, we have our kubelet running. The kubelet can be thought of as like a node agent. So basically, it's an agent or a component running on our node that is taking care that all containers are up and healthy, that everything is running as I expect it to, and so on. And we need, if we have multiple machines, as we have them here, the workloads on those somehow need to talk to each other, right? So sometimes we want communication between them. So we have the kube proxy that enables exactly that. Okay, so we have like one to a lot of nodes, and on each of them we have a runtime, we have a kubelet, we have a kube proxy. But how do we actually manage them? How do we decide what happens in our cluster? This is done by the brain of our Kubernetes cluster, our control plane. And I've visualized it as an external component here, but of course the control plane is running on a node as well, because everything needs a machine to run on. Okay, so we have our control plane. What is in there? First of all, an API server. Because we, as developers, as platform engineers, whatever, want to communicate with our Kubernetes cluster. We want to tell it, hey, please deploy these things, please delete these things, whatever. So we have an API to talk to it. Usually you don't interact with this API directly, but you use tools like kubectl or something like that, that then interacts with the API for you. But every cluster has an API server. And yeah, next thing, we need a place to store our data. This is etcd in most cases, or at least the default case. It's a simple key value store. All the cluster data is stored in there. The control plane is using it to make decisions. And yeah, simply storing data. A more interesting component is the kube scheduler. This one is actually, if you deploy a new workload, a new container to your cluster, something needs to decide on which node to run it, right? So the kube scheduler is doing exactly this. And it sounds boring, but actually it's quite exciting, I think. Because there are things like a container needs resources like CPU and memory. Where do I have enough space for that? A developer has certain requirements for the node, maybe like tool XYZ needs to be installed, or those two tools need to be separated, and so on. So the kube scheduler is taking care of all of that. Next, and nearly last, as you can see, we have the kube controller manager. And this one is a control loop that is basically controlling the whole cluster. It is checking all resources, it is keeping everything alive, it's checking if everything is running as it should be, it's doing the cluster internal communication, and so on. And last but not least, which is somehow optional, somehow not, is the cloud controller manager. You don't need it in local clusters, but you will need it if your cluster is running on AWS, Azure, Google Cloud, whatever, to actually communicate with your cloud provider. So if my cluster is running on AWS and I spawn a new node, I will need an EC2 instance. And the cloud controller manager is doing exactly that. So the kube controller manager decides, hey, we need a new node. Then the cloud controller manager is going ahead and tells AWS, hey, please give me a machine, I need a new node, and is then managing it. And that was a lot of theory and a lot of talking now. I promise this was the longest block of talking. So let's take a look at this in practice and how it looks like. And I hope my screen works better for that. Yeah. Okay, so we're doing everything from scratch today. I hope that the demo gods are with me, but let's see. So what we're doing is, first of all, we are creating a new cluster, and it already first error, sorry. Now, We're creating a new cluster, and we're doing this with Kind, which is like, I always use it for demos, for running Kubernetes locally. I would never use it in production, but it's quite nice for playing around. So now you can see we're creating a Kubernetes cluster, which is called Kind Containers and Beyond demo. It's using the node image 127. It is preparing 3 nodes, writing configuration, starting the control plane, so the brain of the cluster, which we just talked about, and it should be done in a few seconds already. This is the last step, and usually much faster, but we will be there. While this is starting, everything I'm showing here, I also have written it down in like a demo directory in the Git repository. There's a QR code in the end. It's also my cheat sheet for today. So you can try it out all later on. And while I show you that, we're done. We can use our Kind cluster. And let's do like kubectl cluster info first. This kubectl is a CLI that is communicating with the Kubernetes API then. And we can see we are connected to our local cluster. So everything is really here, really the cluster that we just created that is empty. And I will now switch to K9s because it's just nicer to show things and I like using it a lot. But basically everything I'm showing you, you could do with kubectl too. So let's see the nodes we have. So the machines our cluster is running on, all virtual here, of course, but we have our control plane, which is the brain, and 2 worker nodes, which are kind of dumb in this case. Let's check the control plane. We can see we have etcd on here. We have some kind-specific stuff, but we have the API server. We have the controller manager. We have the kube proxy. The scheduler is running on. You don't see the kubelet because it's not running in a container. Oh, sorry. Yeah. Let's check back a worker node. Much less components. We only have the kindnet thingy and the kube proxy again. And of course, you also don't see the container runtime as a container or pod. But yeah. Here it is. So let's go ahead and actually deploy something to our cluster. Because if we check our deployments, it's quite empty. There are a few default things, but nothing that we deployed. So we are going to do kubectl apply -f. And then from the first demo, I prepared a hello world YAML. I'm also going to show it to you in a second. It's pretty simple. You tell Kubernetes, hey, I have the API version apps v1. It's a deployment. It's called hello world in the default namespace because I didn't care. And that's it already. The other important thing, it is running an HTTP bin container that is also named hello world and exposing port 80. And now when we head back to K9s, just because I like it more, you can see we have a new deployment here. It's default. It's in the hello world namespace. This deployment has a pod inside, and the pod is actually running our container, our workload. We can see the logs here, so you can see it's running. It's also listening at port 80. That's it. That's all we need to do to deploy something to Kubernetes. Let me quickly check my cheat sheet if there's something else I want to show you. No, that's nice. Okay, so we have created our first Kubernetes cluster. We have done some very basic deployment and interactions with it. So let's continue and let's see how we can actually make this more interesting and how we can extend Kubernetes. First of all, let's take a look at our architecture again. You know this, we've seen the nodes, we've seen all the components running on there. Of course, the control plane is running on a node as well. But how can we now extend this? First of all, we can install lots of plugins. We can install device plugins, for example, if you want to handle GPUs or something like that. We can install storage plugins, network plugins for like similar things. And that's really cool, but that's not the thing I'm so excited about. So let's keep it. We can also extend the kube scheduler. Like I already told you, it's quite advanced in where to schedule something. But you could also extend it like, hey, always just schedule reports where the image is already present or something like that. Basically, whatever comes to your mind, you could do it here. What you can also do is you can extend the Kubernetes API. So you can create so-called custom resource definitions, just like the deployments we have seen, that you can then deploy to your Kubernetes cluster. And this is actually a pretty cool thing, because the Kubernetes API is becoming a kind of standard slowly in the platform engineering space. And it works pretty well. You just deploy YAML, you give it that, you have lots of inputs you can define. And Everybody knows that there are great ways to work with it. We will see that also later. And by extending that, we can deploy custom things to our Kubernetes server. We could, I don't know, create a Hello World custom resource definition, whatever that is, and then deploy it to Kubernetes. But what do we do with that? What's in for us if we create a custom resource definition we can deploy something to, but we don't know how to manage it? So the second thing we can do about that is create a custom controller. So by that, we can create a custom resource definition and create a custom controller that knows when somebody is creating post Hello World custom resource, the controller will kick in and will do the magic of creating this for us. And this is actually called a Kubernetes operator. So when combining, thank you, a COD and a custom controller, you will get an operator. And they are quite widely used and basically available for lots of things. You could use them for observability reasons, for service meshes, for anything basically, to deploy tools like Kafka, RabbitMQ, and so on. But Kubernetes itself is limited to deploying applications, at least from the standard scope. So wouldn't it be cool if we could deploy everything we need for an application to Kubernetes? So not only the container, but lots of standard applications also have a database. So why can't we deploy this database to Kubernetes as well? And the cool thing is, with custom operators, we can. And we don't even need to write a custom operator, but there is one that's called Crossplane. And this one allows us to basically deploy anything to Kubernetes, take care of it, or anything that has an API endpoint, anything that can be managed via an API, take care of it, reconcile it, and manage it just as Kubernetes resources. But how can just one operator take care of resources on AWS, Azure, Google, Grafana, GitHub, whatever comes to your mind? Would be quite big and not usable, right? So what Crossplane does in that reason is it uses providers. So you install the base operator that's taking care of the lifecycle, and then you can say, hey, I want to create resources in Google Cloud. So you install the Google Cloud provider, or same for Azure, AWS, Grafana, basically whatever. You can also write your own providers if one doesn't exist. The only important thing is the target system needs to be manageable via an API so that you can address it with your provider. And then those providers actually take care of creating the actual resources in the target systems. Okay, I promised not so long talking blocks anymore, so let's take a look at this in practice as well. So we have our Kubernetes cluster here again. This time everything's running. What we need to do next is we need to install Crossplane. And we do that via a simple Helm chart. So we are doing a Helm install Crossplane. It's from the Crossplane stable repository in the Crossplane system namespace, which will be created. Yeah, already deployed. And now let's see what happened to our Kubernetes cluster. Let's go to K9s again. And you can see the Crossplane deployment is already starting. It should be there soon. And what's a really interesting thing now is, I told you when you're extending the Kubernetes API, you're creating a custom resource definition. So let's search for those custom resource definitions. And you will see that there are lots ending with Crossplane IO, or actually all of them, because it's the first thing we installed to our cluster. And one that we have here is providers.package.crossplane.io. And this is exactly what we are going to install now. So when we exit here, there is a file crossplane provider.yaml. And you can see this one is utilizing exactly this API version. We have package.crossplane.io, we have a version included, and it's a provider. And what we are doing is we are installing the GCP storage provider to create a simple bucket on GCP, and it has version 0.35. So let's go ahead and apply this one. 02 crossplane provider.yaml. But now we have the provider installed. We also need to tell it to which Google Cloud project to talk. So we will create a secret. And yes, I have it here, luckily. It's called GCP secret. It's living in the Crossplane system namespace again. And it's from the file where my service account is located. I won't show you that part, but it's just service account JSON. So let's create this. And the last thing to do is to tell Crossplane to actually use this, secret as credentials. So what we are doing here is we are creating a provider configuration. And this one is also of the type GCP outbound IO. So this type was now added to the Kubernetes API by the Google provider. It uses my personal Google fun demo project, and it is referencing the secret in the namespace Crossplane system, which is called GCP secret. So let's also apply this one. 02 Crossplane provider config.yaml. And that's it now. Now we're ready to deploy resources to Google Cloud. So let's do that. Let's deploy a bucket. It has the type storage GCP outbound IO, kind bucket. It is happy that it was created with Crossplane. It's located in EU, and it has a simple label with a key and a value. And it's also referencing the provider config we just created. You could have multiple of them for multiple Google Cloud projects, for example. So let's apply this one as well. Crossplane bucket. And now if we go to K9s again, we will see that we have so first of all, in the custom resource definitions, all these GCP outbound IO things have been added by the provider. And we can now also search for the resource type bucket. And we can see that we have one here that is happy that it was created with Crossplane. And I will quickly switch to the browser because it hasn't been created yet. So I can still click refresh here, and you can see no bucket. But very soon it should actually sync and should be ready and synced here. Let's see if there are any events already. No. So it will just take a bit. But I would say in the next demo, I will show you that the bucket was created, and we will continue from there. Okay, at this time, we know that we can manage our applications with Kubernetes, which is quite basic. But we also know that we can manage the database and application needs with Kubernetes, or the DNS records needs, maybe the static storage bucket it needs, or just anything we need around Kubernetes can be managed with it. We can even create Kubernetes clusters in Kubernetes to go a bit better here. So basically, everything we want to do, we can do it. But how do we now make sure to have a nice deployment workflow? Because if our cluster is that mighty, the traditional workflow might not work. Back then, also when I started working with it, manual deployments have been done a lot. So in this case, you had a Kubernetes cluster, you had a set of developers, and those wanted to deploy to this cluster. So what would be done is give this developer direct cluster access, let them deploy, let them do stuff. And yeah, it works, but it has quite a few drawbacks. First of all, you have no version history. You don't know what is going on. You always just have the state in your cluster. I mean, what we did to improve this was we pushed our manifests to a Git repository and then deployed it with a Jenkins pipeline. But still, people had direct cluster access, people manipulated stuff, we broke stuff again, and it was pretty hard to find out what was changed. Also, in addition to that, I didn't remember, you don't have reviews. So you don't have any other person looking at your changes before you actually do them. So not the situation you want to be in. We are not doing that for code since decades anymore. So why do we do that for the deployments that are actually taking care of our code? In addition to that, rollbacks are pretty hard to do, because if I don't have a clear version history, if I don't know what is going on, how can I roll back to a certain state if I don't know it? And also, if those two developers are touching the same file at the same time, developer A might simply override the changes from developer B, which is definitely not a situation we want to have. So I think we can all agree we need a better solution. Oh yeah, and last thing, direct cluster access. Also, especially in regards to least privilege, not something I want to do. You can fix it with RBACs or with access control. You can make the situation a lot better. But actually, RBAC sounds so easy when you talk about it. And it's so hard to apply it in real life, because you will find yourself in maze of considerations and trying to get things right and so on. So we need something better, right? And luckily, something better exists, and this is GitOps. In this case, same situation. We have a Kubernetes cluster, we have developers, but the developers are not pushing to Kubernetes directly, but they are pushing to a Git repository in this case. And the good thing about that is that we can utilize everything we have learned from software development now in infrastructure and DevOps, platform engineering, whatever you call it as well. And then Kubernetes will go ahead and will pull from this Git repository, get its state, and apply it. So we don't even need to give cluster credentials to anybody. We still need to do for emergencies and stuff like that. But for normal working, we don't need to do. And Kubernetes will get its full state from the Git repository. So by that, we suddenly have like a single source of truth. Because if we want to know what is deployed, we can always go to this Git repository, check what is going on, and that's it. Deployments got much faster for us because instead of having to remember how this kube control command was again, you just do a git commit, git push, and that's it. Rollbacks are much easier because we have Git, we know how to do a git revert since forever, or not forever, but very long. We have a clear version history, which also makes rollbacks a lot easier. And collaboration is much, much easier because again, we can copy, we can learn from software development, and we can collaborate much better. We have pull requests, we have conflicts that we can handle, and so on. And now it's time for another demo. This one is the last one now. Oh, sorry, and security and compliance. As said, we have like PR reviews, we have a 4 eyes principle, and so on. So there are always 2 developers taking a look at our changes. It's much better with compliance to not give people direct cluster access, at least not if they don't really need it. And security is improved as well because Kubernetes is pulling the state from the Git repository instead of us directly pushing to it. And now it's finally time for the demo. Yeah, first of all, let's check back with our Google Cloud bucket. And it is here. It was created with Crossplane. And we can also see in the configuration, if you remember, we set the label, which is a key with a value. It is also here. And what we can do now is we can go ahead and edit this one. And let's search for this key. And let's make it, I don't know, another value. And let's just save it, and K9s will apply it automatically for us. You can see now it's green, it has synced. So let's do a refresh over here again. And immediately our changes to the label have been applied. So there's no clicking around in Google anymore to get your resources, but you can really manage everything as code, which is pretty cool in my opinion. And the same applies for deleting our bucket. We can simply go ahead, delete it, and Crossplane will throw it away for us. And it will also be gone in, sorry for that. It will also be gone over here. Let's also show that in the overview. It is gone. But when I deployed this bucket, I had direct cluster access, and I don't want to have this actually. Also for me, when I have it, I'm usually scared of doing things. So I really prefer having a safe way of working with Kubernetes. So what we are going to do now is we are going to install Argo CD, a GitOps tool that enables us to do exactly that workflow that I just described with the Git repository. So first of all, we're going to create a namespace, which is called Argo CD. And then we're going to deploy some manifests from GitHub in there. Just a side note, I would never do that in production. I would never do it without checking in production. I took a look before the talk, and it's like from the Argo project, installing the manifests. But yes, same applies for Helm charts. And then once we installed Argo CD, I just quickly need to patch the server so that we are able to access it. I want to get the admin secret, which I will show you now because I'm going to shut it down in a few minutes anyways. And as a last step, let's do a port forward to connect to Argo CD. Okay, we are ready to take a look at it. So let's ignore this one. We can now log in with admin and the password I just copied. We don't want to save it. And you can see it's empty. It does not have any resources. It does not recognize any resources in our Kubernetes cluster. And the reason for that, Argo CD is like working with something that's called applications. So you deploy an application and you tell this application, hey, please track this Git repository and deploy all the resources that are inside. And that's exactly what we are going to do now. So I have this Git repository for today. And in here, I have an applications directory. And you can see, for example, I'm deploying a bucket again, which says I was created with Crossplane and GitOps. And the other thing that we have in here is a simple deployment. That's just deployment service account. That's called Hello Kubernetes and a bit more advanced than the previous one. Okay, so let's go ahead and tell Argo CD to take care of this. So I have prepared another YAML for this one, which is in the, I shouldn't change the name of my directories before the talk, which is in here, 03 GitOps apps.yaml. And you can see it is now of the API version Argo project, because also Argo is creating a custom resource definition. It's of kind applications. It's called applications, and it tracks exactly this repository. So you can see Katharina SIG, presentation materials, global Azure Austria, demo, 03 GitOps applications. So what we are going to do is we are going to apply this again. And it was created. When we now go back to Argo CD and reload it, tells me that my permission is denied. That shouldn't happen. Actually, now it is here. You can see we have the applications application, which is taking care of the bucket and our simple application. In the simple application, we can see we have a service account, a service, a deployment, and 3 pods running below that, because I wanted to have more replicas of that one. And we also have a bucket for our application, which was created with Crossplane and GitOps, which should also already be here. Just the same thing as before. Oh, it's not here yet, but it will be synced soon, I'm sure about that. Yeah, you can see it's not ready, not synced, but it's in Kubernetes. It's exactly the same resource as before. So Crossplane will pick it up, or did pick it up, probably already, talk to the GCP API and apply it for us. And with that, that was the last demo. I also want to show you the principles of GitOps. So of the thing we're doing, there are 2 very common tools around it. It's Argo CD, which I just showed you, and Flux, which doesn't have a UI. That's why I didn't choose it for the demo. But basically, everything you deploy to GitOps, the nice thing is it is declarative. So you just define your desired state. Kubernetes, again, takes care of getting to the actual state. You could argue about that. Many people are deploying Helm charts, for example, with GitOps. There are many interesting conversations going on if Helm is declarative or not. In my opinion, not really. So very arguable point. But basically, everything you deploy as YAML is definitely declarative. And Helm is more declarative than not putting something in a written form in a repository. But yeah. Everything must be versioned and immutable, which we automatically have because our repository, which is using Git, is automatically versioned and immutable. It is pulled automatically from the Git repository, and it is continuously reconciled. So if I would now go ahead, connect to Google Cloud, change something in my bucket, Argo CD would notice, or actually Kubernetes, and it would override it immediately again, which is pretty cool because we can be sure with that what we have in our Git repository is the thing that is actually deployed to Kubernetes as well. So what is there to remember from my talk today? Actually, for me, it's that Kubernetes is quite cool for deploying workflows, workloads, but that's it. Then there's Crossplane, which is pretty cool in extending Kubernetes, creating infrastructure for us, giving us the chance to really create a good experience for our developers by combining resources. So Kubernetes and Crossplane, much, much cooler, but still we don't have a good workflow. So by adding the third thing, which is GitOps, in our case with Argo CD, we are getting like all that niceness of being able to create nice flows, nice interactions for developers. In addition, with a good workflow where we can ensure that everything is versioned, that it's immutable, that it's compliant to our standards, and so on. And that's why I wanted to show it to you today. I hope it was not too basic, to be honest. I hope you still enjoyed it. So thank you for listening. If you want to do the demos, I think this is the most important QR code. It leads you directly to the Git repository. The other one is just the slides and your LinkedIn. And with that, thank you for listening. If you have any questions.
I have a question. when you set this up, like on a greenfield, let's say, the best workflow would be to create first the Kubernetes cluster, then Argo CD, and manage also Crossplane installation with Argo CD, and then all the resources with Argo CD, right?
Exactly.
Okay.
What is also a bit the problem for me is, or for us in our team at the moment, we also want to have our Kubernetes cluster managed by Crossplane, because we don't want to have anything where we need to click around in the UI. So it's a bit of a chicken egg problem, because we want to deploy Kubernetes with Crossplane, but you need Kubernetes to deploy Crossplane. So this is something we are currently setting up. For now, we are having it that we deploy our management Kubernetes cluster with Terraform. And then, just as you said, we continue with installing Argo CD and then creating all the other resources.
Okay. So what kind of things are you discussing regarding how to install this first management server?
We actually thought about creating a pipeline where you spin up a local Kubernetes cluster, just like the kind cluster I had. That is then tracking a Git repository that already has all the cluster config inside, is creating our Kubernetes cluster. And then this Kubernetes cluster would again track back to this Git repository and manage itself. And then we could spin down the kind cluster and then it would work again. But we didn't implement it yet, unfortunately. And probably it's not as easy as we think.
Is there also a way like in Terraform where you can see the changes before they are applied? Because I think it could be dangerous to, if suddenly a database is redeployed.
You don't have anything like the Terraform plan output in Terraform. What you have is the pull request you're creating. So basically the pull request shows you hey, I'm going to add this value, but unfortunately you don't have anything like this is going to be recreated or something like that.
Yeah, because that's...
Yeah, it's a bit, I'm personally a bit ambivalent about it, because with Terraform what I don't like that much is you deploy it once and that's it, and then you deploy it again when you have some changes at first. For example, secrets expired because of that and so on. And with Crossplane, you can really have the continuous reconciliation, and you really describe the state in a more declarative way than with Terraform. Because with Terraform, you have loops and functions going on and all of that. And with Crossplane, you don't have that usually. So your state is described in a more clear way than with Terraform usually, at least once you get used to reading it. So for that, you don't directly use it because it gets immediately applied. But you're right, sometimes it was also a bit dangerous for us and also caused problems.
Okay, thanks.
I've got another question. Regarding Crossplane, what are the pitfalls, let's say, and the limitation of Crossplane? Are there certain things it can't do regarding infrastructure, or is it everything you can do? You can do Crossplane basically.
Basically, everything that has an API, you can utilize it with Crossplane, because in the end, it's just calling the APIs. We started using it I would say 1.5, maybe 2 years back. And back then, you would really notice it was still, in his child years where you had problems, you noticed that it's really better. But about half a year ago, they had a release which made it really, really stable. We also had a lot of performance problems back then with the providers, which are fixed now. And by now, personally, I enjoy using it a lot. You still have the problem with the Terraform states that you don't see that with Crossplane, which on the other hand is also understandable, because it's due to the way that Crossplane is working with you push it and you have it directly. Yeah, for me that's the hardest thing. And also what's if you can write with Crossplane, you can combine resources. So now we deployed a deployment and a bucket in separate apps. What you can do is actually you can create a Crossplane composition that combines a deployment, a DNS entry, a database, and so on. And then you just expose this composition to the developer, which is called then application, and has some defaults behind it and so on. And writing those can be quite big and quite complicated in the beginning. So we also had to get used to that. Any other questions?
Is location our Kubernetes clusters are always deployed at the same location, or is there some interregionality? If you deploy in Germany West and North at the same time? And does Kubernetes take it into account if you want to communicate with high performance servers like Redis or something like that?
Yes, you can. So for us, we're in a lucky position. We just deploy to one region, but there are like hybrid clusters, like for multi-regions, or sometimes even also like multi-cloud providers. But I luckily never built this. It would be interesting, even though. But also like, yeah, you can Redis. You could, for example, deploy it directly to Kubernetes, but you could also use the managed service of your cloud provider and then just communicate with that.
But does Kubernetes have like a concept of regionality?
No.
Okay, so it's like there is a Redis server somewhere, and you talk to it no matter if it's in Germany or America.
Yes, I mean, I'm not sure what you could do with like the kube scheduler. To be honest, I didn't have these problems yet that I had to solve. Yeah, I'm sure you could solve it somehow, but I don't know how. Maybe somebody else in the room does.
Yeah, you can have multiple worker nodes in different regions, if that's what you mean. And then you can use taints, for example, and labels to schedule the pods in the correct region.
But how would you ensure that it's talking to the correct Redis instance just by giving it the endpoint? But
Yeah,
there's no
endpoint, or you
automated
can do some
way.
DNS magic that does regional.
Or you deploy different Kubernetes clusters to different regions.
Okay, yeah.
Yeah, if there are no other questions. Thanks a lot for listening. I will be around the whole day, so approach me at any time if something comes up. And have a nice day.